Hello, everybody. Buddies. Welcome to the Funtastic Academy. Hello, everyone, and welcome to the Funtastic Academy with me, Ayush Prasad. Today, we are going to talk about electromagnetism. Well, I say today, but actually, it's going to be a series of episodes on electromagnetism. And this is just the first one. But let's just quickly get out of the way of our quiz question. Last episode's quiz question was, what is a Hoffman voltmeter? Well, a Hoffman voltmeter is simply a device that measures voltage used during electrolysis. So that you can measure the amount of material that's been deposited while you did the electrolysis. With that out of the way, let's start talking about the history of electromagnetism. Now, for literal ages, people had known about electricity and magnetism. But where does the word magnet come from? Well, it comes from a place called Magnesia, where a bunch of magnets had been found a long time ago straight in the rocks. And these magnets had the property of attaching pieces of iron and steel to them. This was thousands of years ago, not that recent. What was recent was the observation that electricity and magnetism are one and the same thing. Now, this discovery was made by one Hans Christian Oersted. He was at a university lecture teaching about electricity and magnetism. He had a wire to demonstrate electricity and a compass to demonstrate magnetism. Now, the reason he was doing this is not because electricity and magnetism were related, it's just because he wanted to teach two things at the same time. But then, when he turned on the wire, the most amazing thing happened. The compass started to spin. This was the first hint that electricity and magnetism were connected. Now this happened in 1820. In 1831, Michael Faraday, you remember him for the electrolysis video, discovered electromagnetic induction. That's a big word, but it means a really simple thing. All it means is that if you pass a magnet through a coil of wire, electricity will flow through that coil. Now, later in 1861, a man named James Clerk Maxwell published a treatise in which he condensed all electromagnetic knowledge of the time into 20 equations with 20 variables. And these are called Maxwell's equations. In 1864, Maxwell used these equations to develop new observations about light. Now, am I going to teach you all 20 equations that Maxwell made? Of course not. That would be too much. Later, a man named Maxwell and Heaviside, who by the way, definitely does not get the credit he deserves, simplified all those 20 equations into just 4. He actually invented a new field of mathematics along the way, vector analysis. But we won't be getting into that now. All you need to know is that there are 4 equations and that these 4 equations, called Maxwell-Heaviside equations, govern electromagnetism. So, before we teach you about these 4 equations, I first need to tell you about 3 simple things. These 3 things I need to tell you about are the Lorentz force law, divergence, and curl. Now probably sitting there thinking, wait, hold your horses there. What do any of these words mean? Well, first we need to talk about field. A field is not just a place where you play sports. In science, it has a different meaning. A field is a scalar or vector assigned to every point in space. Now, in our very first video, we talked about scalars and vectors. A scalar is just a number. Numbers have size, but a vector is an arrow. Arrows can have size and direction. Now, for this perspective, a vector field is just an arrow at every point in space. This is an example of the vector field. And it turns out electricity and magnetism can be represented as vector fields. The electric field is really easy to understand. It's just the direction and speed that a positive charge would move it was placed at that point in the field. The magnetic field is a bit more complicated. You can understand it using the right hand rule, but I won't be getting into that. Now, we can talk about the three things I mentioned. First, the Lorentz first law. Now, what do these symbols mean? Well, F is the force on a particle, E is the electric field, V is velocity or speed, B is the magnetic field, I don't know why, and Q is the charge of a particle. I also don't know why. But anyway, this equation is like Newton's second law, F equals ma. It tells you how a particle can move with the electric and magnetic fields. All this states is the force on any electrically charged particle equals the charge on that particle times the sum of the electric field and the particle's velocity times the magnetic field. So if we know the numbers of the field, we can figure out how a particle moves. Now we need to figure out the actual values of the field. This is where Maxwell's equations come in. Now on to the second point, divergence. Divergence is actually really easy to understand. It's basically how much the field comes out from a particular point. For example, take this field. At this point in the field, all of the arrows are coming out. So the divergence here is positive. At this point over here, as much field comes in as it's coming back out. So the divergence here is 0. And at this point over here, all the field is coming in. So the divergence is negative. It's really easy to conceptually understand. Now, the third and final thing I want to talk about is curl. Now, curl is divergence's cousin. It's also very simple to understand. Basically, it says, if you put a twig in this point, how will the twig turn? If it turns counterclockwise, then that curl is positive. But if it turns clockwise, curl is negative. Now, it's really obvious that the field itself is curly. For example, if we put a twig here, it will turn this direction, so the curl is positive. But also, in some situations, it can be non-obvious. For example, this field down here doesn't seem to have a curl. But watch what happens when we put a twig standing over here. Look, the field strength is higher up here than here. So the twig turns clockwise and the curl becomes negative. So, now we know about the Lorentz first law, divergence, and curl. So, in summary, what did we learn today? Well, we started off the episode by discussing a few key events in the study of electromagnetism. Then we discussed fields, a key component in understanding it. Finally, we discussed three key elements: the Lorentz first law, divergence, and curl. These three elements interplay with each other in the understanding of Maxwell's equations, which we will talk about in the next episode. Until then, I leave you with this quiz question. Remember how in the beginning of the episode we discussed about Hans Christian Oersted discovering electromagnetism? Well, he actually has a unit named after him. obviously called the Oersted. Now, your quiz question is A. What does the Oersted measure? And B. Why is it not an official SI unit? Answer these quiz questions, and till then, I'll see you